Hello friends, welcome to a new series of video on embedded Android development. So in this first video, we'll be covering Android boot sequence. So what are the boot process in an Android system, or whenever you're doing a custom build, you need to understand its boot sequence. So just similar in way in which we learn Linux boot up sequence, in which like bootloader, the kernel, and the what all starts up. In the similar way, we are going to study the Android boot sequence in a practical way. So I have built the emulator for the Android 11, the latest thing. So let us try to understand and how we can understand the boot flow sequence in this Android thing. So the easiest way is to log in through the ADB shell. I've already logged in. So you can maybe I'll show you the get prop details. This is actually the Android 11 emulator thing build which I've done for the x86 and 64 build. So if you go here, so we can even see the get prop, all the build details. So here you can see it is Android 11. So now to understand the build sequence, maybe I'll zoom in a little more. We have to just understand that if we do ps under -ef, we'll get all the processes. So it has listed all the processes. Now let's go one by one how it has started and what all the things are happening. So to understand this, you have to understand what is this PID and the process PID and the name here, whatever the command which is given here, that thing. So if you see this, you will, if you understand this process ID, it is the unique number which is given in the order of the sequence in which it is created. And the parent process ID is the process ID of the parent which creates it. So first one is the first process ID is always the init. So init second stage. Actually, there are earlier inits in the Android system which are liquid, like mounting the different partition, those things. So we here we'll start off with Android second stage. So this will give an good idea, and other things are related to mostly to the system. So we can skip that. So you can find this code in the system core init.cpp, where it starts the second stage init. Second stage, here you can find second stage init. You have to search through the source code, second stage main. So from here you can start analyzing the code. The early first stage init or other processes it is doing, that also you can see, but we'll be covering from this process id 1. So in this so we have to understand this is started first, then the process id through is the kernel. Whatever starts with k is related to kernel. So kernel thread daemons are started. So you have to first go through this, the first two you have to keep remember. The first process id is the init thing, and the second is the kernel thread id. So now if we can see, now start analyzing based on who are the parents of it. So we can see these are a bunch of twos. Parent process ids are two. So these are related to the kernel things, like kernel worker thing is there, and cpu those things are there. So these are related to kernel, so that those things are related to the kernel we can skip. So now we can see now this process id again one. So the init has started what? The init has started a vendor init. So this vendor init, why it has come is because of the treble architecture. They have separated out the system and vendor partition. So to start the vendor init script parallelly with the system thing, this vendor init was created. So this vendor init with the SC Linux policy, everything proper SC Linux policy, you can it will start the vendor init processes. So for this, it was this is what this our init second stage init has started this. So next one more process is the U event daemon. So few more daemons our thing is our init is starting. This is required for the listening the kernel events to mount the dev partitions. So the different things you can see, dev loop 1, dev loop 3, those kind of things are happening. Again, still few more kernel things are running. So next thing is one more daemon our init is starting is the log daemon. This is our logcat, those kind of things. Logger daemon, our init process has started. This is our PID, this is process ID, and this is PPID, that is the parent process ID, which I'm highlighting here. So then it is starting again. You can see one more one. So this is low memory killer daemon. So whichever process is if you are going, the process is going under low memory, this will kill up the few of the processes for us after the starting. So it is started at the after init only starts this low memory killer. So the next important thing, again you can see one things are the this thing, service manager and the hardware service manager. These are little bit similar. This will keep track upon what all applications are running. So once the system server starts running, it has to register here our to our service manager that I have started this process. So these two are also important thing here. Next, which our process ID one is starting is the shell. Okay, the shell commands which we are able to run. Those things are one. Then the two things are related to the kernel, as I have mentioned again. So next thing with one are these two processes. So this thing is suspend. This is for the suspend service, and this is for the android tracing service. This a trace means android trace. So this is nothing but for tracing within the device itself. Sometimes we want to debug, so the logging without any connections, we want to log into the device. That's why this service is required. So it is also started very with very first with the init itself. And this system to suspend, you would have heard. Now this was a little bit famous because in many mi phones and poco phones, this was giving problem and draining the battery, something they messed up with this thing. So few of the things error in the recent times was because of this thing only. Instead of making the battery life more, this thing had created some problem and draining the battery. So next we'll move on to other these two are again this thing related to kernels. This develops means it would have listened to the that event d which I have told, that daemon. So next things are a few of the things which are started are here. So main thing here is our okay, this NTD and STD, this tombstone things will cover later. The main thing is here our zygote process is started. This will start all the services and the applications whichever we require. So this zygote 62 is the ART, that is the Android runtime thing which we are which has created. So now it is starting the different services. You can see this I explained in the previous video, this neural network service, different Wi-Fi service, USB service, it has started. Then the main thing should have been our server, system server. So we'll see. So now this zygote has become zygote is now main. So let's dig into it. There are 64-bit zygote and there is 32-bit zygote, because this is a Android runtime. The runtime thing, there will be applications of 32-bit and 64-bit. So they will take care which has to start, which zygote has to start which application. So we have to see now this process ID 299 and 300. So now next applications, the zygote will start everything. So let's move on to this 299 and 300. We'll see these are again process one, different services. The script init based on the RC script, these are things are started. Next to two which we told 219, our zygote is 299 and 300. This thing will keep in mind. So 299, this are two that 299 was that net related net id related things, that is IP tables related things. So that thing it has started here. So now we will move on to this again, are different processes which are started. 299, this is the main thing. Our zygote has started the system server. Now the system server will start all the applications and will register with the service manager which I showed you above. So once this thing is started, now applications can start. So we can see 299 com dot bluetooth application has started. Then system emulator, because this is emulator related things has started. Then again you can see 300 is zygote 64. So that is, it is starting a web view zygote. So for the web applications it has started. Then yeah, phone related things and those things it has started. So those things we can see. Then then different applications, Android videos, those kind of applications is in, and this is now this shell command which I have shown. So now we have gone through the complete processes which are running in the uh, Android. So the main things again I will highlight. One is the process ID one that we should keep track, and two is related to the kernel daemon. So kernel, whichever process is started by two is related to the kernel, and one is the init process. So while we went on tracking one, we saw that log daemon. This was one, and a low memory killer. And the next, the main thing was the service manager, where the system service will come and register all the applications here. So these two are the for hardware service manager, and this thing is for the software service manager. Then we were there few more ones in it which were started. This we skipped actually the time. This is related to emulator, and this is key store is related to the security keys, maintaining those keys thing. So that is also started by one. Then we covered this suspend and Android trace also, which are started by one, that is the init process. Then we moved on to the zygote and the zygote 64. Then based on this, then we tracked to the service. Where is our we were tracked to our system server, which will register with the service manager. So next, all the applications are able to start. So like this, we have tracked the all the applications in the emulator. To go through the code, you can start tracking from the init.rc. This is in the system core init, init.cpp. This is the second stage main which we started. So once you move on, you'll pass through all the init scripts and the vendor init scripts. Those things also you will be able to trace everything. So this was the this thing topic covered for the Android boot sequence. So I'll be covering few more Android embedded related things in this series of videos, and we'll be creating a playlist. So subscribe to my channels for more videos on related to Android.